So on your test, this is problem number 13. Why do baseball catchers wear a mitt rather than using just their bare hands? So you can read through some of the choices, and it talks about the force being reduced. And it's all about the force or momentum. So we have two equations that lets us deal with force. F net equals ma, or F, this is also a net as well, times T equals m change in V. Right? I see multiple things here about momentum, so I would look at that route. So this one, it's because of the increased area. Do we have anything in these equations that talk about area? No. The force on the catcher's hand is reduced because the mitt decreases the time of the impact. Well, if this went down, and this should be the same for both problems, because it's the same mass, and then both of them go from however fast the ball was going to 0. So that's the same. So if the right side of the equation is constant, the left side also has to balance back out. So if time goes down, force goes up. That's not going to be good. C says a force on a catcher's hand is reduced because the mitt increases the time. Let's test that one out. So if the time goes up, to balance it out, F net has to go down. So that's looking good. If we looked at D, the baseball's change in momentum is reduced. We said that is a constant. Last one, E, the impulse delivered to the catcher's hand is reduced due to the presence of the mitt. Well, this is also equal to change in momentum, which is the same as the impulse. So that should not change. So therefore, our answer has to be C. Alright, so back to this problem on 14. I have the correct one. So I have block 1, mass 1, block 2, mass 2 are sitting along the same line on a frictionless, that's important, there's no friction here, a frictionless surface. When they collide, here's the graph of their velocities. This says which block has a greater mass and what information indicates this. This is a collision. Right? Anytime you have a collision, you can look at your momentum and impulse equations. So I like this. Force times time equals m change in V equals change in momentum. Right? What information does this problem ask about? This asks about masses and velocities. Right? So I'm going to have to do something with this. Right? So if we look at this, we can see they have the same mass, I believe. No, they have different masses because it's asking about that. What else could we come up with here? Well, I need mass. I'm trying to solve that. Hey, I have change in velocities in the problem. The last thing we can do is look at either force and time or change in momentum. Let's look at force. The only force that's there is the force between the two objects. Block of 1 on 2 and block of 2 on 1. So that force is the same. The collision time is also the same. So I know that m delta v of block 1 equals m delta v of block 2. Let's put everything in here. So these two have to equal each other. And we have the velocities from our graph. I look at block 1, it starts out at 4 and ends up at 3. So this one has a negative 3 on this side for its change in velocity. I switched the wrong side, so let's change that back. This is now which block? That's block 1 and the change in velocity 1. Right. This is mass 2, change in 2. This is still mass 1, and this is still mass 2. So let's finish off with what is the change in velocity of block 2. I start at negative 1, and I end up at positive 1. The change in velocity there is 2 meters per second. Right. So I look here, I could see what numbers would I put in so they are equal. Let's just make up some numbers that could work. So what number times 3, let's just make up a 1 kilogram for this, times 3. So this side is 3, so what would 2 meters per second have to be? So now I had to pause this video, okay, and figure this out. You could do the same, do a little bit of algebra, Okay, and we figured out with the calculator that this mass had to equal 1.5 on this problem times 2, and that will get me 3. So I can now see which mass has to be larger. Let's see. So finally, the last one, we have 2 that could be block 2, so C or D. But if we noticed, we had to look up here at the change in velocity. So only D has a change in velocity, so it has to be D on this one. Alright, on this question, number 15, a lightweight toy truck crashes head-on into a heavier toy truck. Which of the following statements is true as a result of the collision? So it talks here about impulse. So I know impulse is force times time equals impulse. So when they collide, how do the forces compare? Well, what are the forces when we collide a toy car, I just make boxes everything, into a toy truck, which is just going to be larger? Okay, so larger. Well, what forces do we have on this? We're looking in the x direction only. Well, I have force of car on truck, and then I have force of truck on car. Hopefully by now you figured this out. Those are Newton's third law pairs. They are equal and opposite. So both of these have the same force. The collision is between these two. That's the same. So then I will have the same impulse, so it can't be that. Next, the car will experience a greater change in momentum. Well, hopefully you realize impulse is the same thing as change in momentum. So can't be that one. The last one, the magnitude of the acceleration by the car will be greater than that experienced by the truck. So my handy dandy favorite equation, F equals ma. So here, they both have the same force. So this has to stay constant. This overall has to stay constant. So if the mass goes down, because it's a car, it's smaller than the truck, then the acceleration has to go up. This next problem, we're going a little out of order. Right? So I'm missing some information here. The information I need. So in this problem, here's the information that we're given. It wants to know a 2 kilogram mass as this diagram happens. It says at 4 seconds, what is the final velocity of the 2 kilogram mass after 4 seconds? And it starts off at 3 meters per second. So anytime we have a graph, we know I've threatened to hit you guys if you don't know this. So I have to look at either slope or area. Well, we know area is force times time. Okay, so force times time. And that equals, well, how could I relate it? This is area. How could I relate that to my variables down below? Well, I could say this is force times time, or the area, equals, I'm looking for the final velocity. The only one that have velocities there is m delta v. Okay. So now let's solve this area. I'd break it up into shapes. So I have this shape and that shape. Now this is where it gets a little tricky. You don't have to do some stuff. But this triangle, that's a positive triangle, is the exact same thing as this triangle. So those two areas would cancel out. So now all I have to do is find my area. So the first little area, it's 2 in this direction and 2 in this direction. And it's a square. So I do length times width. So it's 2 times 2. So that is 4 for my area there. The next one, the base is 2 again. The height, though, is from 2 up to 6. So that's 4. But then I have to divide that by 2. So 4 divided by 1 second. So I'm not sure if I misspoke, but essentially calculating this area should be 4. And this one is also 4. So my area equals 8 overall. Some of you did that with a great job. Right? But the issue that we had from there is once we plugged everything into the equation. So my area is 8. The mass is 2. Then I have to do the change in V. So I started off at 3. Okay. What can I do? Well, from this, I want change in V, which is the same as V final minus V initial. So the V final is what I am looking for, and the V initial is 3. So doing this algebra, 8 divided by 2 gives me 4 equals V minus 3. So V equals 7 meters per second. All right, I went back and looked at problem number 16. Here it talks about impulse. There's only one equation that goes with impulse. That could be J, net we're looking for. That could be force, net, times T. That could also be M delta V. So then we can look at our work here and see which ones we could solve. So I'm given mass. Ooh. Come on now. I'm given mass with those kilograms. I'm given a velocity, but that's an initial velocity. I'm given a final velocity. So I have, that's all of these right here. So I'm looking for this. So the mass we saw was 2 kilograms. The velocity initial was -5 meters per second. That's the one that got most of you. And then the last one is minus a positive 3 meters per second. So 2 times 5 minus 3 is 8. So then impulse has to equal 16. If you didn't pay attention to direction, you would have got B, just like I warned you if you didn't pay attention to direction. So really, really, really watch out for direction.